is x squared minus x minus 1 equals to 0. So to complete the square is to reorganize this equation into a form where we can use the square root method that you've just learned about. And there's a trick to this. It's not very intuitive. Somebody had to stumble upon this. In general, you first have to make sure this coefficient is 1. Now it already is, but if that was, say, a 2x squared there, then our first step would be to divide everything by that 2. So that now I have a 1x squared. So that's always the first step in completing the square, is to make sure your leading coefficient, that's the number multiplying x squared, is equal to 1. It's already done. So next I'm going to take the constant term and shift it to the right side. So I'm going to, in this case, add 1 to both sides. And this gives me x squared minus x. I'm going to leave a space here, equals to positive 1. All right, now the next step is really the completing the square step, and it's the part that's not terribly intuitive. But if you take college algebra, you'll use completing the square to work with circles. And if you take trigonometry, you'll use it again to work with parabolas and hyperbolas and ellipses. It comes in handy in various places in mathematics, this process of completing the square. And here's how it works. I'm going to take half of the coefficient of x. So the linear term is the first power term. The coefficient here is negative 1. So I'm going to take half of negative 1, and that would be negative 1/2. And I'm going to square that number and add it to both sides of the equation. So again, you take half of the coefficient of x, square it, add that to both sides of the equation. I have to add to both sides to keep the equation in balance, and we'll see shortly why we do that. All right, so this becomes negative 1/2 quantity squared is positive 1/4. So I have x squared minus x plus 1/4. And on the right side, I've got 1 plus 1/4. So it may not be readily apparent, but if you do complete the square correctly, then the left side is a perfect square, trinomial. You know, this factors as x minus 1/2 times x minus 1/2. Now, we're not used to factoring with fractions like that, but you can verify that. If you multiply this out, you would get that expression on the left side. So the left side factors as a perfect square. By that I mean both these binomial factors are identical. So we could rewrite this as x minus 1/2 all raised to the second power. On the right side, 1 plus 1/4 would be 4/4 plus 1/4, and that would be 5/4. So what did that accomplish? I have a term squared equal to a constant number. So now we can use the square root method to solve this problem. So I'm going to take the square root of both sides, and there's a plus or minus symbol there. So that eliminates the exponent of 2 on the left side. I have x minus 1/2 equals to plus or minus the square root of 5 over 2. So notice that I was able to simplify the denominator as just an integer. Square root of 4 is just 2. And finally, we'll add 1/2 to both sides. So x would equal to 1/2 plus or minus the square root of 5 over 2. So I just added 1/2 to both sides. And as will just about always happen, we have the same denominators here. And so it makes it easy to combine this into a single fraction, and that would be the typical thing to do. So I need to make a little room here, and the answer to the problem is x equals to 1 plus or minus the square root of 5 over 2. So there you go. There's the solution. Now that can be written as two separate answers. X equals to 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. So there's the two separate answers. It turns out this is the golden mean number, because if you work this out, and we're going to look at this with calculators, but if you run this through a calculator, this is approximately 1.618. Oops. 1.618. And this number is negative 0.618. So there we go. The golden mean then is about 1.618. Okay, so there you have it. This is a process is called completing the square. When I was in high school, I learned this stuff over. We had a whole week to drill completing the square. We got good at it because we spent all week doing completing the square. You don't really have that luxury to focus on a little technique like that in college. We have to learn too much too fast. So here's the good news. I want you to see the completing the square. You've seen it now. You don't have to learn it. Not for this course, as far as I'm concerned. Because the other method we're going to use to solve is called the quadratic formula method. And it's faster to learn, and so that makes it more practical. If you want to use completing the square to solve problems, I'm perfectly fine with that. I'm as fast using both ways myself because I've did all that practice years ago. But quadratic formula is probably a more practical thing to learn. So anyway, there's completing the square, and we'll move on.